Hi, this is Leonardo, and in this video I'm going to show you the new addition to the package of modules. It's called Caudal, and it's a mechanical chaos source. And this chaos source is based on this model, which is it's a multi-segment pendulum that has no friction. So what happens when you connect four bars like this, and you have no friction, which is not possible in real life, and you just let it move, we can have this kind of behavior. And it's hard, this is a chaotic model, so it's gonna be difficult to predict how it will behave in real life. So what I did was taking this model and making it much more efficient in order to run in real time as a Pcb module, and we have it here. So this is a very simple module. I have simplified many things in order to make it as compact as possible, and also as interactive as possible, because in the original model there are many things that we can change. For example, the friction, we can change the mass of the segments, we can change the distance, and I have simplified it. So what we are seeing here is every segment. We have four segments: A, B, C, and D, and each segment has three outputs. One that is the position in the X coordinate, position in the Y coordinate, and the angle that the pendulum is forms. So I have connected every segment to a scope, and we can see the trajectories that the segments take. And these positions are normalized, so all of them output voltage between +5 and -5, and we can see what kind of trajectories these segments generate. In the case of the first segment, it only rotates in like that, because if we remember the model, is the first segment attached to the center. This is the second segment, the third, and the fourth segment. And the fourth segment tends to be a little bit more chaotic than the others. So we can see that this is less chaotic, and this is the most chaotic of them. And if we take a look at the signals, this is the way they look. And how to use this model it's very simple. I'm gonna put back all of them in XY mode. Let's put it like that, so we can see the movement. So it only has two controls. One is the speed, and the second is the energy. So the speed, I think it's obvious. It makes it move slower or faster. This is as slow as it gets. It takes quite a long time to move. I'm going to increase it a little bit so we can see how it starts moving. This is as fast as it gets. I'm gonna put it somewhere there. The next control is the energy. In fact, this energy knob changes many of the parameters of the model. For example, it alters the mass. It also alters the gravity. So we will not see an effect here, because it's a chaotic model, so we don't really know what happens. But once when we use it, we can hear a difference. So this control can be used, for example, to make variations. So what I'm gonna do, I'm gonna take this VCO, and I'm gonna create a flux which is the other module that I have released, and it was developed especially for processing the signals that Caudal outputs. I'm gonna take one of these signals, and I'm just gonna put it in. I'm gonna turn off the sampler hold and comparator, and just connect this to the pitch of the oscillator, so we can hear there how it behaves. I can change the speed, and with Flux we can change the range of the signal, of the offset. And something interesting to do here as well is using Flux in sample and hold mode. So we're gonna take the clock output here, change to sample and hold, and once we have this signal we can add a quantizer, for example. Now let's take a look at the buttons. So we have pairs of buttons and also gate inputs. And what we can do with this, let's take a look at the first, which is the hit. So what it does, it just puts all the segments of the pendulum in a different position, and I'm gonna make it slower, and also randomly inserts or removes energy, so it just starts in a different place. And we can take another clock, for example, like this clock division. So every fourth clock, it just gives a gate, and which changes the initial position of the pendulum. The next part is the reverse. So what it does, it just changes all the velocities of the segments of the pendulum and just goes backwards. This is very useful if we want to create, for example, some kind of repetitive melodies. I'm going to use as well this one. So every fourth is pressing the reverse, and we can see how all the segments are like going backwards every time that they receive a pulse. And this is a good moment to use the energy. I'm gonna give an 8, and I'm gonna make it faster. So if we change the energy, the trajectories change slightly. The next two buttons are the store and recall. So store, what makes it saves the current state of the pendulum. So I'm just gonna press it. So it just saves a state, and I can recall it by pressing this button. So it goes exactly to the state that I stored. And I can use again, for example, a clock signal, and it's just going back to the same state. And I can use again the energy to change slightly the pattern. and we have 12 outputs. Oh, and one nice thing about this model is that it generates very natural transitions, as you can see in the scopes. It moves really nice. And of course we can also modulate these parameters. For example, let's use an LFO and just change the speed. Or of course you can also modulate Caudal with its own output. And we can use other signals from here. We can use it to control other parameters. Let's just test something. We can also use another signal to, for example, changing the range of the melody, or the offset, I mean. Well, the possibilities are limitless, and it's up to you finding different ways of using all these signals, and also in combination with Flux. So that's it. Just subscribe to this channel to get updates on the new modules, and also remember that you can donate so I can keep developing these modules. And thank you very much, and see you.